Welcome back to Daily Dose of Space. For decades, dark matter has been one of the pillars of modern cosmology. We don't see it, we don't touch it, but without it, galaxies should not behave the way they do. Stars would fly apart, structures would never form. The universe would look completely different. Dark matter is everywhere, or at least that's what we thought. Because a few years ago, astronomers found something that should not exist. A galaxy that appears to be missing almost all of its dark matter. A galaxy that rotates, holds together, and survives in a way that directly contradicts one of the most fundamental assumptions in astrophysics. Today, we're exploring the strange case of a galaxy that may be breaking the rules of the universe, or revealing that we never fully understood those rules in the first place. Why dark matter matters at all. To understand why this discovery is so unsettling, we need to understand what dark matter actually does. When astronomers measure how fast stars orbit inside galaxies, the numbers don't add up. The visible matter, stars, gas, dust, simply doesn't provide enough gravity to keep galaxies intact. According to classical physics, they should tear themselves apart. But they don't. Something invisible is adding mass. Something is shaping galaxies on the largest scales. This unseen component was named dark matter, and over time, it became essential to every major model of cosmic structure. Galaxies are thought to form inside vast halos of dark matter. Without those halos, galaxies should not exist as stable systems. Which makes the next discovery deeply uncomfortable. The galaxy that shouldn't hold together. The galaxy is called NGC 1052-DF2. It's a faint, diffuse galaxy located about 65 million light-years away, orbiting a much larger elliptical galaxy. At first glance, it looks unremarkable. A ghostly collection of stars spread thinly across space. But when astronomers began measuring the motion of stars inside DF2, they noticed something strange. The stars were moving far more slowly than expected. So slowly, in fact, that the galaxy's visible mass alone seemed sufficient to explain their motion. There was no need for an additional dark matter component. According to the measurements, DF2 contained little to no dark matter at all. If correct, this galaxy shouldn't exist. Why this was a problem for everything. This wasn't just an odd result. It was a direct challenge to the dark matter paradigm. If galaxies form inside dark matter halos, then a galaxy without dark matter should not form. Or, at the very least, it should not survive for long. Yet DF2 appeared stable. This immediately sparked controversy. Some researchers suggested the measurements were wrong. Distance estimates could be off. Stellar velocities could be misinterpreted. The galaxy might not be what it appeared to be. Others proposed more radical explanations. Perhaps this galaxy lost its dark matter through gravitational interactions with its larger neighbor. Maybe violent tidal forces stripped away the dark matter halo, leaving behind only stars. But even this explanation raised new questions. Dark matter is thought to be more loosely bound than stars. If anything, it should be easier to strip away. But stripping almost all of it while leaving the galaxy intact is extremely difficult to explain. The data didn't kill dark matter, but it did injure something else: our confidence. The debate that followed. As more observations came in, the picture became more complicated. Some studies suggested DF2 might be farther away than initially thought. If true, the stellar motions would make more sense, and dark matter could still be present after all. Other teams doubled down, arguing that even with revised distances, the dark matter content was still unusually low. Then came another discovery, a second galaxy, NGC 1052-DF4 appeared to show similar properties. One galaxy could be a fluke. Two starts to look like a pattern. At this point, the debate shifted. This was no longer about whether dark matter exists, but about whether its relationship with visible matter is as simple as we assumed. And that question cuts much deeper. What this really means. Even if DF2 and DF4 turn out to contain some dark matter after all, they remain extreme outliers. They sit at the edge of what our models predict. And that matters, because science doesn't move forward by confirming what we already believe. It moves forward when observations refuse to cooperate. These galaxies don't disprove dark matter, but they do force us to ask uncomfortable questions about how galaxies form, evolve, and survive in complex environments. They also remind us that the universe does not owe us simplicity. Sometimes it gives us objects that sit right on the boundary between explanation and contradiction. And it is precisely there, at that boundary, that the most important discoveries tend to happen. A galaxy without dark matter should not exist. Yet DF2 is there, quietly orbiting, refusing to fit neatly into our theories. And the most unsettling possibility is not that dark matter is wrong, but that we still don't fully understand how galaxies truly work.